What's up, everybody? This is Lou at Lightpoint Scientific. Going to be talking today about scene photogrammetry for collision reconstruction, specifically how to map evidence that is no longer available to you using a single photograph. And this is part of my advanced photogrammetry for collision reconstruction course, which I recently started offering and expect to offer probably once or twice a year from now on. So the main purpose of this type of photogrammetry, of course, is to map roadway evidence that is captured in photographs but no longer exists at the time of your investigation. That evidence could be tire marks, scrapes, gouges, the final rest of each vehicle involved, debris, footprints, whatever's pertinent in your case. It's very helpful to us, especially on the private side of things, since we're hired, 1, 2, 3, sometimes more than that, several years anyway, after the collision, we're often hired. So the roadway evidence no longer remains, but it could be, of course, really helpful to us if the measurements were not taken at the time of the collision initially. You can also use this process to salvage measurements if something was missed during the initial investigation. So unlike vehicular damage photogrammetry, it's often possible to obtain scene measurements, from just one photograph. And that is because we are going to be defining the surface on which this evidence exists, taking out essentially any uncertainty in the z direction, which makes the mathematics much less intense, and you can actually get measurements from just one photograph. So here, for illustration purposes, if this was the only photograph that you had, and you wanted to determine the final rest of this motorcycle, the actual location of the gouges that lead to the final rest of the motorcycle, how long the gouges were, maybe you're interested in where the debris is. It is possible to map all of this evidence using just this photograph, well, in most cases anyway, as long as some of this background context still exists. If the roadway hasn't been repaved or there's not some sort of major construction that's gone on between the time of the accident and the time of your investigation. So what you want to do is identify points that are still likely to remain at the time that you go back out to the site to perform your inspection. And what these points are going to do, they're going to serve as control points, and they will help basically they will allow for the program, the photogrammetry program, and here we're going to be using PhotoModeler, to determine where the camera was that took this photograph and what the focal length of that camera is. And once that's established, then we can start taking measurements on this photograph. So in this case, you can see there's a knee in the seam sealer off to the left side of the photograph, which we have a red arrow on now. That's a point that I would be interested in measuring when I went back out there. It's something that's visible in this photograph. It's something that I think I can measure, and it's distinct enough so I can put a point right on it. Same with the end of this white line, end of the dashed line there in the background, the adjacent dashed line, the base of this fence post that's very likely to still be there when I go back out. Hopefully the curb hasn't been repainted and I can map this junction of the red painted curb with the non-painted curb, the end of the center line. Hopefully all this stuff's there. And what I do is I basically take a printed version of this and then actually ID with a number, each point, and hand that to whoever's operating the total station and have them take those measurements and label them according to my numbering system. So at the end of the day, I have a DXF file from the total station that aligns with my numbering system, and you'll see how that comes into play in a little bit. So you map these previously identified points. I generally like to do it with a total station. You can use a scanner, and sometimes, I've used scanner data several times. It's a little bit more cumbersome because you're dealing with millions of points as opposed to just 30 or 60 points, whatever you map with a total station. It's just a lot more streamlined with a total station. and you can be very deliberate with what you're measuring when you're out there with a total station. Sometimes these control points are very subtle. You know, it could be a specific letter on a sign or a bolt head or something very small, and it's a lot easier to get that exact measurement with a total station, in my opinion, compared with a scanner. So when I do these site inspections and I know that I'm going to be doing some sort of photogrammetry, I will go out there, I'll do the normal thing with scanners, but I will also bring a total station out there and take measurements specifically for photogrammetry and ultimately merge the total station data with the scan data, and then the photogrammetry data will come into that at the end as well. All right, so let's bump over to PhotoModeler and kind of look at this process a little bit. So this is just the first screen that you'll see when you come into PhotoModeler. This type of project is going to be under the category of manual modeling. This screen is going to pop up and just ask you to bring in the photograph that you're interested in working with. And here is the photograph that we're going to be dealing with. So first, it's going to be trying to match up the parameters of that photograph with a camera that is in your library. Of course, in these cases, almost always we're not going to have a calibrated camera for that single photograph. So it's going to pop up and say, hey, I don't see the camera that's relating to this photograph. Either point me to the camera, and if you can calibrate it, great. If you can get an exemplar camera and calibrate it. But most of the time we'll be saying, hey, we don't know what this camera is. It's an unknown camera, and I want you to solve for the parameters of this camera by control points. And you can see here it says you need 5 or more control points, and these are the control points that we measured earlier when we were at our site. So now you're in the project, you have this photograph. You can see here that we have a rolled over Ford Ranger. There is a Ford Explorer that's stopped here. We'd like to know the final rest positions of these vehicles, and then there is a tire mark here that's kind of on an arc that leads in the general direction of this Ford Ranger. That tire mark was actually caused by the left rear tire of the Ford Ranger, as it was kind of it was yawing and ultimately rolled over. But so this is what we want. We want to know where this yaw mark is, how long it is, the curvature of it, so that we can eventually perform an analysis to determine how fast everybody is going, which is usually the question. So close this out. So the next thing we're going to do after we have brought the photograph in is bring in the control measurements. And that is done by clicking this third button over here with a little globe on top of it that's called the External Geometry Explorer. And when you click on that button, this is the window that's going to pop up. You will see there's a little plus sign here with a coordinate system and a ruler here. There's a button that says Add Import External Geometry. And when you click that, you'll get a few options of what this external geometry that you're bringing in will do. And in this case, we want the geometry to control the solution, and we're going to be using known XYZ locations to do that. And these, of course, are going to come from a file in this case that is a DXF file that was created from our total station data at the site inspection. That's blank, you can see, but if you click on the 3 dots here, it'll just ask you to browse to the DXF file, or I think there's several different file types you can use, but here we're using a DXF file to define this whole project. The units we're going to set to feet in this case. They are fixed. We don't want the photogrammetric solution to mess with the control points on any level. Those are fixed and immovable. Once you click that and bring it in, you'll get a list of all of the points that were obtained with your total station at the time of your site inspection. And you can see I have a bunch here. Some of these are points that we discussed earlier, where you're identifying points that were hopefully visible in the photograph and at the time of your site inspection. But then there's a bunch of these points that we're just using to facilitate merging this total station data with scanner data. And some of these points are just taken to create a surface underneath the pertinent evidence, so that we can kind of draw on that surface, and you'll see that process in a second. So this whole numbering convention here is consistent with the numbering convention that we laid out before we even went to our site. Before I go to the site at all, I'll pull up the photograph that I'm interested in. I'll label every point that I hope that we can measure at the time of our site inspection, and then I'll put a number on that point. And that whoever's operating the total station will number that point accordingly, so that both of our systems are synced up, and it makes the actual modeling go much easier in PhotoModeler. Here you can see I have numbers ranging from 11 to 48, and that's just because in this case we actually had several photographs that we had to bring in this manner, and that's a tutorial that I'll probably do a little bit down the line, but here we're just using this as a single photo illustration. So going back over to PhotoModeler, we're going to start assigning each one of these points to a specific point on the photograph. And to do that, the first one was point number 11. You'll click this little triangle up here that says Activate Control Mark Assign Mode. So we're just going to be saying, hey, point number 11 is the top right of the T in stop. So now that's marked. And right when I start marking points in PhotoModeler, what I like to do is go to View, Visibility on Photos, and turn on IDs, residuals, and then target areas. Target areas won't matter here, but I like to have that on. So now you can see that the project number is 1, and the IP number is 11. IP meaning imported point number is 11, and that's right. So I'm ready to continue on. Point number 12 is the corner of this stop line here. Point number 13 is the bottom of the P. Point number 14 is way over here, and that's the junction of this blue and white paint, I believe, right here. Point number 16 is a bolt head over here. And there's a bunch of bolt heads right here, so I'm trying to make sure I pick the right one. Hopefully that's it. Point number 17 is another bolt head. So you can see here that if I was trying to rely on scan data to obtain the center of this bolt head, it'd be a little bit difficult. It's something that's easier done with the total station, in my opinion. And then bolt head number 17 is up here. Point number 17. And then point 48 is down here. That's the corner of this, which you can just barely see this edge of the stop line. So now you can see my max residual is 10.7 pixels, and if you click on this, it'll actually bring up that point number. So it's 10.77, point number 1 on photo 1. So if you click that, it'll highlight that point, or it should. Here, now it highlights it, and you can see that it's off by that length here. And I can see it should be probably a little bit over here, just about right there. And that gets me down to 9.46. In projects like this, I'd like to keep it under 10, and it depends on what quality photograph you're working with. If it's an original JPEG, then it's likely to be lower. If it's a scanned PDF or something to that effect, it's going to be higher. In this case, this is a PDF image, so 10 is fine. And you can go around and kind of monkey with these things a little bit, but you don't want to go anywhere that doesn't make sense. So if I put it here, sure, I could get my residual down to 5.73. But at the end of the day, that doesn't make any sense. If somebody else is looking at this project, they're going to say, yeah, your residual is 5.73, but it's bogus. This point should be over here. So the actual residual is something like 10.4, 9.8, somewhere in that ballpark. So now that we have that done, we can go, by hitting F7, you can go into the 3D viewer and pull up all of the points that were measured with the total station, as well as these points with a triangle around them, which means that they were used as these control points. So if you click on the settings wheel over here in the corner, we say, all right, let's look at the total stations, the camera stations. I want to see their ID numbers, and then show me the rays of that camera when it's selected. So you can see here's camera station 1. This tells us exactly where the camera is, and you can kind of move around and see if that makes sense. You can also turn on the IDs here too. so you can figure out kind of what angle you're looking at. Point number 11. Let me turn off the imported ones. So imports, turn off those IDs, so we're just dealing with the ones that we're actually using here. And that makes sense. And so when we click on this, we're going to see the light ray from the point of interest going to the camera. And that's essentially how the camera position is defined. It's an intersection of all of those light rays. And now when you go up to project cameras, you can see we have one camera. It's an unnamed default camera, but its focal length is 8.98 millimeters. So it's figured out what the focal length of the camera is, it's figured out where the camera is, but then if you look at the lens distortions, you can see they're all at 0. So there's not enough information here for it to do any sort of deep camera calibration, including distortions in different portions of the lens. But you get its focal length, you get its position, and that's enough for you to be able to map this evidence. So at that point, the next thing that you want to do is define a surface to draw on. So that's what we're going to do. We're going to define a surface that's underneath this yaw mark, and then we're just basically going to trace that yaw mark on that surface, and we'll be done. So I generally like to do this in the 3D viewer, and here I will turn on the imported point IDs, and the imported points, of course, are the total station data. Excuse me. And what I'd like to do in this case is I'll already have, I'll already kind of have a list of my the points that will be used for this surface drawing. So here you go into this this kind of drop-down menu here that has the blue rectangle with a plus sign in it, and click path mode. So this is going to draw a surface between all the points that we're selecting right now. So we'll hit 11, 47, if it'll select it there, 47, 46, 31, 10, 44, and 41. And then you can right click and hit finish surface. So now that surface is there. And then we can go back into our photograph to make sure that that surface is in fact underneath the evidence of interest. If you go view visibility on photos, there's a surfaces checkbox here for 3D, and now we can see, okay, that surface is indeed underneath the evidence of interest, so we're safe to start drawing or tracing the yaw mark on that surface. So once I have that figured out, I'll generally turn that off so it's not distracting. Okay, so the next stage is we're going to be telling it, hey, we're going to be drawing lines, and they're going to be on that surface that we just created. So you click mark surface points in line mode. You can do a curve or whatever's in most interesting to you. So I will, or best suited, I should say. I will, in this case, I'm just going to kind of make a quick trace to show it to you, but you might want to actually trace the extents of it to get the thickness and everything as well. Here, I'm going to say that the tire mark starts here, kind of comes through here, and I'm just left clicking along this whole entire mark, tracing his extents. And then right click to finish. Okay, so now we have all these points, they're on the surface, and we can go into our 3D viewer and take a peek at them. So if you click it, it's red and you get a little bit more contrast, and you can see this mark that we're dealing with. And then now this is basically established. The position of this yaw mark is established, the length of it can be measured easily, and the coordinates of this yaw mark are all consistent with the coordinate system of your total station data. And the scale has been set because it knows the X, Y, Z coordinates of all of the control points. So you could go into the photograph and go into measuring mode, and just click between a couple of them and just say, okay, well, that's 15 feet. So just for the for sake of illustration, let's just measure between the beginning and the end, and we get it about 37, 38 feet. So at that point, that's kind of just basically a gut check is what I generally do for measurements within PhotoModeler. In a situation like this, I will then export this as a DXF. And like I said, the coordinate system is already consistent with your total station data, which hopefully is already consistent with your scan data. At this point, when you export this PhotoModeler data, you bring it into a CAD program like Rhino or something, it will just seamlessly merge with the rest of your data, and you'll have the location and dimensions, of that yaw mark. So to do that, though, it's really simple. You go File, Export and Print Data, Export Model, 3D DXF, and you can select the layers. If you've created any layers, which layers you want to export. If you want to select export the points, the point ID services, you can turn certain things on and off. Just click Export. You don't want to overwrite your control points, of course. Port case tutorial. It's as simple that you get a little summary of what has been exported, and then that is something that can be brought straight into Rhino. So hopefully this is helpful. If you have any questions, feel free to shoot me an email. Email is lou@lightpointdata.com. There's some other tutorials up at lightpointdata.com. You can see our course schedule up there, and hopefully this helps. Thanks.